Yeah, Shishani can say it. Let's start off. The last thing we did was the shell car formulas. Hope everyone by-hearted them. It's important you remember them. Sure, let's start off. Are the scams on? So these are all the formulas there, hollow sphere and solid sphere. Let's see a question on this so that you get used to the formulas. So we have a shell and we have a solid sphere. This will cover all the formulas. So we have a solid charged sphere enclosed by a hollow sphere. So this charge is Q, radius R. This charge is Q, radius is 2R. So O is the center. This is point A. This is point B, and this is point C. There are 4 points. O to A ka distance is R by 2. O to B ka distance is 3R by 2. O to C ka distance is 5R by 2. There are 4 different points. Find the field and the potential at OABC. Get this. This was a directly mains question. Huh? Find the potential at A. Ye mains question tha. That too only solid sphere. Not even shell also is not there. Mains and bits with direct questions you get. Let's get them. I hope everyone copied the formulas yesterday. Just formula substitution. There's nothing hi-fi there. Get it. 4 minutes. 1 minute for each. Find the field and potential. So total 8 questions these are. At O, A, B, C. O is the center. OA is R by 2. OB is 3R by 2. OC is 5R by 2. It's a solid charged sphere enclosed by a hollow sphere. Anyone confused with a question? Please ask. Yeah, this is the first question, Harish. We'll finish off major chunk today. I think next 2 more classes. Next Friday, we should wrap up the chapter. Gravitation won't take more than 3 classes, 3 to 4. Because we'll be skipping all the basic similar questions. We'll not be doing that. We'll do some practice problems, but if you understood electrostatics, your gravitation, the starting part is clear at least. Okay, Nanya. Again, I'm telling you, everyone, you guys need to do parallel with me. You can't be more than, maximum 1 week behind me. Maximum. But I would ideally say 3 days. Whatever I'm solving, be parallel with me. Like I told you last time, jitna bhi kiya tha, you can finish off HCV 1 to 35 questions. You should have finished it by now. If you do like that, you'll be parallel with me. So when the time our portion gets over, right? I'm telling you again, by the time the portion gets over, you will have barely 1.5 to 2 months left for exam JEE mains. You won't have 6 months or 7 months for revision. 1.5 months में मुझे doubt ही लग रहा है. Because I tell you what happened last year. Portion got over somewhere at November 2nd week of first week. Pace people, they rushed the portion like mad and they finished by November 1st week. But the rate at which they were going last year, right? The portion was supposed to get over by December end. The moment getting it, so they were chilled out. उनको लग रहा था April में mains exam होगा. But the moment the notification came out, exam is in Jan first week. They just rushed the portion They took, physics class, 8 hours physics class every day for 1 week. They finished the portion. No one understood, no one got anything. वो अलग story है. But ठीक है, that is one part of the story. Then what happened? We thought, okay, चलो syllabus हो गया, we'll do something. Then suddenly all these college people started waking up. When was the last time you went to college for practicals? Nah, you must not have even seen where is the college properly. You don't know who the hell is a teacher also. For some reason, they all woke up and they started calling the students. आपको practicals के लिए आना पड़ेगा, compulsory. You have to come and give the prelim exams and all. Bloody, we had 6 weeks for the mains exam. Already full pressure में था. On top of it, this was one extra. People wasted almost 10 to 12 days on that. Option nahi tha. We didn't have an option. We had to do it. So this year also it will happen. That's what I'm telling you. You will not have time. The last 6 weeks of time which you have to use at least 3 weeks for chemistry revision. Inorganic, organic, बैठ के पूरा by heart करना पड़ेगा तुझे NCERT से. Everything comes from NCERT chemistry. 100 में आराम से you can score 70. Being a physics teacher, I'm telling you, you have to mug up chemistry in the end. Understand? Last 6 weeks में 3 weeks will go for chemistry only. बाकी 3 weeks में maths and physics करना पड़ेगा. So be parallel with me. Try to keep up. Let's keep going. What is the answer for the first one? Let me show you each one. So what I will do, right? I will take for a solid sphere and hollow sphere separately. You just need to add them. So the main thing in this formula, right? You need to ask yourself, is the point inside or outside? If it is inside, use the inside of the formula. Outside, use outside of the specific formula. So first for point O, the field will be solid sphere. What is the field at the center? 0. Hollow sphere. What is the field at the center? 0. Luckily, both are 0. Potential. At the solid sphere, what is the potential at the center? It is not 0. Be very careful. Many people goofed up there. If you put R is equal to 0 here, what do you get? See, the potential at the center will be 3kq by 2r. It is not 0. Most people do that mistake. So the potential at the center is 3kq by 2r. It's a scalar quantity. What is hollow sphere? Kq by radius of the sphere, r. Check. This is okay answer. For point A, the field k, q, small r is r by 2 by r cube. What is the field inside a hollow sphere? 0. Potential k, q by 2 r cube into 3r square minus r by 2 whole square. This was a question directly because the question is the formula is so messed up, people don't remember. What is the potential inside kq by 2r for a hollow sphere? You just need to see where is the point for the solid sphere, where is the point for the hollow sphere, and apply the appropriate formula. Please check for O&A. Anyone not clear, not convinced, confused, please ask. I'll explain again. But this is very important. Gravitation में exactly same आएगा. K का place में G, Q का place में M, and just one minus sign. Ditto formulas. Please have a look at this. If you got this, can you try for B and C? I'll give you 2 more minutes. You got this, try for B and C.
So can you show the question?
यही क्वेश्चन है दिख रहा है ना लेफ्ट साइड.
No, I want to center same है ना दोनों का.
I should punch you रे. You're not there in front of me. Center तो same है लेना God. अभी तक क्या कर रहा थे? Sleeping क्या same diagram रे.
Okay.
You didn't have your dinner ना?
No.
That's why you're hungry. You're eating the questions now. देखो. Happens when you didn't eat food, many things happen. It's okay. I can understand your pain. Try. Just get this thing. I'll get some water and go. I just finished a class without a break. Let's see. What is B ka answer? So the field B ke liye, now see, the point B is outside the solid sphere. This is how you always tell yourself. B is outside the solid sphere. Outside the solid sphere, the formula will behave like a point charge. KQ by small r square. Small r is 3r by 2 whole square. Point B is still inside the hollow sphere, so 0. Potential. The point B is outside the solid sphere, so KQ by small r. The point is still inside. KQ by radius of the sphere, 2r. This is also 2r, my mistake. That was a mistake. This is KQ by 2r. That is for B. Point C. C is outside for both of them. KQ by 5r by 2, KQ by 5r by 2. For potential also it is, square. See, even I do goof ups. KQ by 5r by 2, so be careful. Easy one, but unnecessarily you'll miss up and you'll lose 5 marks. Check your answers. If you got this, I think your formulas are decent. Any doubts on this? Next one. Can I turn the page? Reena, clear na? Labdi? Nishita?
Yes.
Dipanshu, clear? Hasni, clear? Arushi? Harsh? Next one. Let's say instead of a full shell, if you just take an half shell. So basically, this is a charged uniformly charged hemisphere. Okay. So O is the center. So A is some point to the side. So the question is, how is the field ka direction? 1, 2, 3, 4. So ऐसा options होगा. So what is the direction of the electric field at point A? Options are 1, 2, 3, 4. Which is the option? What is the direction of electric field? Center to obvious tha, it is down. But what is the direction of electric field at point A? Is it in the direction of 1, 2, 3, or 4? Check. Think. Okay, Ritam said something. Let's see others. I'll give you a minute. Let's do like this, okay? So if you take a shell, since we don't know the direction of the field, let it be Ex and Ey. Agreed? Two components hoga. You can write the field in terms of I cap, J cap. Now, if I take a similar shell, one more shell like this, by symmetry, this point also should be Ey and this point also should be Ex. Agreed? Identical. Now, if I combine them, I'll get one full shell. So from this logic, Ey will cancel. At this point, you'll have field 2Ex. What is the field inside the shell? What is the field inside a hollow shell? 0. That means this should be 0. Therefore, Ex is 0. So therefore, only Ey exists. Now implies only Ey can exist. So what is the answer? 3, na? So if you look at the diagram there, how it looks, the entire this bottom surface which you have, no matter which point you take, the field is always down. That is the best part about this thing. The field is always down vertically. Are you getting it? I took a random point. So anywhere on this, the field is this way only. There is no horizontal component. Please check this thing. It's a good theoretical question. These are the kind of questions you can expect in mains and this thing. Bits. Clear? Easy one, but a good one.
So it was positive, that's why I took EY as down.
Yeah.
Okay.
Next thing. We have a charged sphere with a tunnel. Okay. So this is a small tunnel here. So this charge is plus Q, radius R. Here you have a minus Q charge. Mass M is dropped into the tunnel. So this point is A and this point is B. Find the time taken to go from A to B and the speed at the center of the sphere. Find time taken to go from A to B. And speed at the center. Get this. So we have a minus Q charge, mass M. The big sphere got charges plus Q and radius R. You released it from rest, from the top of a tunnel. Exact same question we'll see in gravitation also. So when you release it, it will go inside because it is attraction, no? Negative. So once you are at the center, field is 0. Once the charge comes here, what will happen? It will pull it back again. So it will actually start oscillating in the tunnel. It's an SHM. Try. I'll give you a minute or two.
So, but it will have some velocity, so it will go away.
Yeah. Who will have velocity?
The minus Q charge.
You dropped it from rest, right? So when it reaches the other end, also it will be at rest only.
Okay.
It can't gain extra energy from somewhere. How do you do this? Try. I'll give you a minute. It's an SHM, everyone. Just figure out that equation A is equal to minus omega square x. See. What is the field inside the solid sphere? Let's say the charge Q is somewhere here at a distance x. So if you look at the force, what will be the force? The field, the force on this will be charge Q into field. So the field will be K Q x by R cube into Q. I'm not taking the sign because the direction is already pointing downward. The force is equal to Q into E bar. So E at a distance x will be KQ x by R cube. Minus indicates attraction. So this is the force that we're talking about. Oh yeah, एक step. That's it. Force is equal to minus mass into acceleration. So acceleration is equal to minus k q small q by mr cube is equal to x. This is looking like a is equal to minus omega square x. Therefore, the time period will be 2 pi root over m r cube by k q cube. But this is the full time period, okay? So time taken from A to B will be only half of the oscillation because A is the extreme position, B is another extreme position. Center will be a mean where the force is 0. You're only asking time from one extreme to another extreme. What about the speed at the center? Speed at the center is nothing but the maximum speed because it is the mean position. What is maximum speed? Amplitude into omega. What is amplitude? Radius. Omega is this. R into root over k q by mr cube. K q by mr. This distance will be the amplitude, obviously. Extreme position. You're starting from rest, so that is extreme. Amplitude is R. Please check. You can just solve the entire question with SHM. Or you could have taken this as state 1, state 2, and conserved energy from state 1 to state 2. That would give you the velocity. Check the steps. SHM, solid sphere.
Sir, here we also took change. That's why we don't took mg now.
There is no gravity record, Shaurya. It is a force between charges.
Okay.
There is no gravity. There's no earth somewhere here. Earth कहाँ पे यहाँ पे?
No, but I thought कि ऐसा charge रखा है उसका mass है तो लगेगा ये mg.
But mg is coming because of whom?
Earth.
Where is earth here?
Okay.
There is no earth here. All clear with this?
Sir, one doubt.
Hmm.
Sir, here, why did you take small r as x?
ले small r, कुछ फर्क नहीं पड़ेगा. You guys are used to seeing a is equal to minus omega square x, na? I will just write a is equal to minus omega small r. Got it? But you guys are used to seeing x, so I kept it in x, nothing much. X is a displacement from mean position. All clear with this? So let's say we have a positive charge here, plus q and radius r. And let's say we have a minus q charge with a mass m projected with speed u. This distance is b. Okay, this is very far. Shaurya, there is no gravity here. There's no earth, anything. It is only interaction between the charges, okay? This is a fixed solid sphere. Now tell me, if I leave this charge, what do you think will happen? How will the path look like? Approximately, how should the path look like? A minus charge and a positive charge. If you throw it from very far, what do you think will the path look like? If I throw very slowly, what will happen? It will come and hit like this. If I throw very fast, you'll go like this. If I throw with a certain velocity, you will just miss the sphere. Agreed? Depending on how fast you throw, I can get any of the paths, right? So the question is, find u minimum so that you just miss the collision. Find the minimum speed of the particle so that it does not collide with the sphere. Get this? How do you do this? Again, what should I use? Remember, I keep telling you this thing every time. You have two weapons with you: force equations and torque equations. Second weapons are conservations. You have three conservations: momentum, energy, and angular momentum. So here, which one do you think I should use? The force and torque or conservations?
Conservation.
Conservations. You know what gives you the hint? Look at the word.
U
Find
minimum.
a U minimum. Find the maximum. Find the highest position. Find the lowest position. Find after a long time. Matlab, you don't care what is happening in the middle. These are the kind of words, which will give you a hint. You have to use conservations. Great. Abhi, we have three conservations. What conservations can I use? Can I use linear momentum?
No.
Q?
External force.
Who is that external force?
That big sphere
Attraction,
of.
na?
Yes.
So linear momentum gaya. Can I conserve energy?
Yes.
Electrostatic force is conservative or non-conservative?
Conservative.
Electrostatic for conservative, right? See, one simple idea I'll tell you. How do you know something is conservative? If you have a potential energy, electrostatic potential energy, gravitational potential energy, spring potential energy, all these are conservative. You define potential only for conservative forces. Okay? So, is there any dissipative forces like friction, viscosity, kuch hai yahan pe? Nothing.
No.
So, energy is conserved. What about angular momentum? Is angular momentum conserved? Is angular momentum conserved?
No.
Why?
Sir, because it is going with you, there will be some torque now. Because of the sphere.
Because you're going with speed, you'll have a torque, or because of the force, you'll have a torque.
Because of the force I'm telling.
Now, this force is acting which way, everyone? When you're here, force kis taraf tha? Towards the center. When the
Yes.
charge is here, where is the force? Towards the center. When you're here, where is the force? Towards the center. Is there any point about which torque is zero? Center, na? Torque about the center is zero. No matter how much you travel, the force will always pass through the center. So torque about the center is zero. Therefore, angular momentum about the center is conserved. So a small trick, you can remember this. Generally, 99% of the time it works. Generally, if particle moves in any path, in a path other than circle or straight line. So if it is not going in a straight line or circle, we can use angular momentum is applied. This is a general observation. Mostly angular momentum is conserved. Mostly angular momentum conservation has to be used because there is no other way to solve. Because if you're not going in a circle or a straight line, if you're going in some random path, 11th and 12th, right, we don't have the sufficient maths to solve such kind of equations. So in 11th and 12th physics, the only way to solve such kind of equations or paths is conservation of angular momentum. Mostly angular momentum conservation has to be used. This is not a concept, this is just a general idea. You can keep this thing. If you see a particle going in parabola, hyperbola, ellipse, when you see these kind of things, angular momentum, there is no other way to solve because we don't have that kind of max, in 11th and 12th to solve problems. So let's solve how to do this thing. See. Let me go to the next page. So this is there, plus q and radius r. This is your minus q and mass m. So this guy is just missing the planet and going like this. So this is your state 1 when you just miss this state 2. When you're just missing the planet, velocity kaisa hoga? Tangential, right? You're just missing the planet. V ka value I don't know. This is the center. Now, if you observe, the attraction force is towards the center. When you're here, attraction force is towards the center. When you're here, attraction force is towards the center. Can you see? No matter how much you travel, the force is always towards the center. since force of attraction is always towards the center, torque about the center is 0. Therefore, angular momentum is conserved about the center. Therefore, torque about center is 0 and L bar about center is conserved. So state 1, state 2. State 1, energy in state 1 is equal to energy in state 2. State 1 energy, kinetic energy, half mu square. Potential energy, 0 because you're very far. State 2, kinetic energy, half mv square. Potential energy, K, Q1, Q2 by R. This is equation 1. Angular momentum is conserved. State 1 is equal to state 2. How do you conserve angular momentum, everyone? Perpendicular distance, na? What is the perpendicular distance? B. Even though it is very far, when you are solving angular momentum, you take the velocity and drop the perpendicular, isn't it? You take m, r perpendicular into v. R is not the distance between them. R is the perpendicular distance. So this will be m r perpendicular into v1 is equal to m r2 perpendicular into v2. Mm cancels. Initial r perpendicular is b, velocity is u. This is r and this is v. This is equation 2. Two equations, two unknowns. V is equal to bu by r. Take this and put it in this equation. You end up with half m u square minus b square u square by r square is equal to minus k q by r. You want to find u ka value, na? Sub shift kar lena us side. 2k r by b square u square b square minus r square ka root. That's your velocity. Check. Energy, angular momentum. Two equations, answer aa jayega. There are two variables here. You don't know u also, you don't know v also. You don't know the initial speed. That's what you have to find, minimum. You don't know v also, final speed, when it is just missing the thing. Exact same question is there in gravitation. Because gravitation is always attractive, right? So automatically ho jayega. Suppose if both are positive, can you tell me how will the diagram look like? If this was plus q and m, this is plus q, how will the diagram look? Aisa na? Rutherford alpha scattering experiment, remember? That is Rutherford experiment, na? ZE, nucleus, and this is an alpha particle. Rutherford gold foil experiment. That would be Rutherford ka thing. So that we will see in modern physics. So both are positive, the path would look like that. Please have a look at this step. It's a pretty good problem, both in gravity and both in electro. हाँ दीपांशु.
Where in that yoga expression में नीचे एक mass का term है.
हाँ mass का term आएगा.
Yes.
You're right. I'm just testing you guys whether you're seeing it or not. And Deepanshu has passed the test with flying colors. That's what the teacher should say, right? And he forgets something. So there. All clear with this? Any doubts? Anyone didn't get it? Pretty good question. So make sure. So if you're going in Harena.
Can you repeat the last part? I was not here.
We are just playing a joke, right? Which important nahi tha. Which part? You are there till here?
Yes, sir.
Yeah, bas wahi tha. I was just saying this is an important question both in gravity and electro.
Okay,
And I was
sir.
saying instead of using negative charge, if you use a positive charge, path aisa hoga.
Okay, sir.
That was Rutherford gold foil experiment, na? Alpha
Yeah.
scattering. All clear? Great. Next one. Let's do something little more weird. This will be a good advanced problem. Let's say we have a uniformly charged sphere. Charge rho, that is volume charge density. That is a charge per unit volume. Radius r. Uniformly charged solid sphere. Now tell me one thing. we learned like charges repel. That means if you have a charge here, this charge is pushing, this is pushing, this is pushing, this is pushing, everyone is repelling, right? That means the entire sphere is trying to explode, isn't it? The entire sphere is trying to expand. So that means the entire sphere is under tension, isn't it? So due to repulsion between the charges, the sphere is under tension. That means if the sphere is really not strong, it will break into pieces and fly away. The sphere is under pressure. Find the pressure as function of small r. Fluid mechanics का question types. Find the pressure at a distance x from center. So the entire sphere is under a lot of pressure trying to expand because of repulsion. So this will generate a pressure inside the sphere. What is the pressure value as a function of x? This will be a proper advanced question. It's a good one. Get it? Mains में tough one, advanced में easy to moderate. Later on, we'll see in electrostatics. How much charge should I keep so that the sphere will burst? I can even frame a question of that sort. How do we do this? Try. Everyone should give it a try. Think about it logically. It's a good one. This will be a paragraph level question. This 29 will be a good question. We can take them as results actually. We'll do for solid sphere, then I'll show you a result for hollow sphere also. Think for a minute or two. I'll help you out. See. Let's say from the center at a distance x, take a small slice, okay? Able to visualize how is it? So we take a small slice dx at a distance x. I'll just draw a bigger figure here. Yes, able to visualize a small this thing. Let the area be A. A is very small. Or its thickness is dx. So the volume of this small thing will be area into thickness. So इसमें charge होगा density into volume. So rho A dx. Now on this small piece, if you observe, there's a pressure from outside P plus dP into area. This pressure is pushing inside. There's a pressure from inside P into area. So basically, because of the small charge, right, the pressure inside and outside is P and P plus dP. Make sense? So the pressure is there. And what about the centrifugal, this repulsion force? Repulsion force will be E into dq. And what is the electric field at a distance x? K q x by r cube. Are you getting what is happening? Because of that small repulsion, pressure increased by dp. Is that making sense? Sure, everyone? Because of the small dp, the pressure increased by dp because of that E dq. So if you write the pressure difference here, dp into area is equal to E into dq, right? So dp area E will be k q by r cube into x rho area dx. Area will cancel, integrate on both sides. This will be k q rho by r cube integral x dx. So here, where is the pressure zero here, everyone? Can you tell me where will the pressure be zero here?
Ends.
And na, why? If you look at the diagram here, look at this point here at the center. Everyone is pulling it, isn't it? This guy is pulling it, this guy is pulling it, this guy is pulling it, this guy is pulling it. Pressure is maximum at the center. Outside, there is no one to pull you, right? Pressure is zero at the surface.
Sir, is it like that rod which was rotating?
Rod ka problem tha. Yeah.
Yes.
So this limits will go from R to X, and this will go from 0 to P. So if I just solve this, I'll put it in the next space. So the pressure P will be K Q rho. The result is more important, everyone. R cube x square by 2, limits will go from x to r. This will be K Q rho to R cube. Actually, ना एक minus n आना चाहिए कहीं पे तो. R square minus x square. I will just convert this. Rho is nothing but q by 4 by 3 pi r cube. So this is 1 by 4 pi epsilon r cube. That is k ka value. To q rho r square minus x square. So you can write this thing as 3 rho is q by 4 pi r cube. So this guy becomes rho square by 2 epsilon r square minus x square. This is the pressure inside a solid sphere as function of x. At the center, put x is equal to 0. You'll get the pressure rho square r square by 2 epsilon. It's a good result, right? Have a look at the steps, what we did. Everyone is getting this? Got the logic what we did, right? At a distance, it took such a small strip. Because of that repulsion, pressure on both the sides is different. So that small difference in pressure is A dq. And we just integrated this. Have a look at this. I know A minus sign now will be a little confusing, but the idea is, since actually, right, this is actually tension, it is pulling. It is not pressure, it is actually tension because the material is pulling it. But okay, for simplicity, let's keep it that way for it will be more easy to understand as pressure.
So one
Because
doubt.
here is a harsh.
So the dp is caused by the charge EdQ,
Yeah.
but like the other pressure P is caused by tension only.
Array, this P is caused by the repulsion due to all these charges na here. That way. Now you know na Harushi.
Sir, can you tell again that
Now you
minus?
learned it. First time it will never strike. First time it will never strike. You should see some models, right? So now you know.
Yes.
Minus, and I'm saying this is actually tension, right? They pull, they don't push.
Sir, but beforeward, you told that key in maths we assume functions increasing. That's why.
तो वही तो किया मैंने ना. That's why I took ना P plus GPA.
Acha, okay.
Clear? Now the same question, but another thing, we will not do the derivation for this. But if you have a hollow shell, result is more important. This will again encounter in surface tension, elasticity. So if you have a charge here, which is hollow shell, previous one was solid. Now what will happen? Think about it. Every charge will repel every other charge, agreed? So because of this, the shell will be under a lot of pressure. So this thing is called field pressure. Field pressure because this is the pressure because of electrostatic repulsion. So this is the pressure on the surface due to electrostatic repulsion. It is given by sigma square by 2 epsilon. Mark it up. Huh? In total physics, you have 3 types of pressures. One is the fluid pressure, second is field pressure, third is radiation pressure, which will come in modern physics. Whenever a light falls on a surface, it exerts a pressure. We call it radiation pressure. So we have 3 types of pressure. Projected area, those sub concepts all are valid. They just behave exactly like fluid pressure. And something more about this result is also valid for any random shaped conductor. If you have any random shaped conductor whose charge density is sigma, it experiences a repulsion. The pressure P is given by sigma square by 2 epsilon. We'll not see the derivation. The result is important. So let's put it up. So this is about the pressures in electrostatic. Solid sphere ka pressure and hollow sphere ka pressure. This is the pressure on the surface, not inside.
Sir, its derivation is same like the previous one.
Yeah, you take a small element and do.
Okay.
Clear with this?
Sir, inside it will be 0.
Yeah.
Okay.
Inside कुछ है ही नहीं है ना, field is 0. Clear, everyone? Can I turn the page? This is another standard question, right? I think this we can do in gravitation also. This is a good one, right? We have mercury droplets. Of potential V. So एक drop का potential is V. So mercury droplets, right? Mercury is a conductor. Charge stays only on the surface. So basically they behave like hollow shells. They're solid spheres, but charge is only on the surface. Distributed only on the surface. Because mercury is a conducting liquid. Potential V, n mercury drops of potential V are combined to form one big droplet. Find the potential of the big droplet. So basically you have mercury ka spheres, small ones, identical. Sabka potential V hai. Like that we have n of them. When you combine them, you got one big sphere. So what is this potential? Is my question clear? So you can just assume the charge is there only on the surface. How much charge we don't know. Potential is given V karke. So when you combine all of them, you get one big drop. If the small drop ka potential is V, and if you have n drops, what is the potential of the big drop? This was a J question, right?
Sir, energy conservation.
I am asking for potential, right? करो एनर्जी कंजर्व करके बताओ आंसर. You can't just add it up, right? What is the potential of a sphere, everyone? Sphere का potential क्या था surface में? Sphere का potential formula on the surface, what is it? KQ by R. Hollow sphere का भी same formula था, KQ by R surface पे. So when you combine all of them, do you think the radius will become R? If अगर इसका radius R है, तो इसका radius will be n times R क्या? No. Radius won't add, gods. When you add droplets, what is conserved?
Volume.
Volume. Radius नहीं है. First find the radius of the big sphere. Try. If n small spheres of radius small r are combined, find the radius of the big sphere. पहले वो calculate करो. Try. Everyone should give it a try. Give it a try. Any answers? Got the radius?
Yes.
Radius was easy, right? See now that simple volume conservation. When you add n drops, what is the volume? N into 4 by 3 pi small r cube is equal to 4 by 3 pi capital R cube. So r will be n to the power of 1 by 3 into small r. This is the radius of the big drop. All clear? This is a conservation of volume. Radius won't add up, volume will add. Next thing, what about the charge? Charge is conserved. So if you assume charge q is on the small sphere, let q be the charge. We don't know how much is the charge. Let q be the charge on small sphere. Then the potential V is given by kq by r. Now on the big sphere, what will be the charge? Charge conserved now.
NQ.
NQ, right? This is the charge on the big sphere. Charge to add हो जाएगा directly. Radius add नहीं होगा. This is the charge on big sphere. And what is the radius of the big sphere? N power 1 by 3 r. So what is the potential of the big sphere? K q by r. K q became n times small q. R became n to the power of 1 by 3 by small r. This is n to the power of 2 by 3 by kq by small r, which is nothing but V. Check. So it is n to the power of 2 by 3 into the potential of the small drops. It's a pretty good question. Check it out. Easy? Good one. Manageable. Now see, these are all our standard models. Now, how do you know you have to do like this? You should have seen some of the models. Let's see. Don't think like, you will sit there and meditate and suddenly, the ideas will start popping up. If you're learning architecture, what they do, they teach you hundreds of, buildings come models. Not because, you'll sit there and meditate and one day suddenly a new design will come. You are learning how to solve different models so that if something new thing pops up, you'll be able to take ideas from different things. Right? So idea was tha. That is a catch. Tomorrow, what they'll ask you, simple thing. Let's say there are small cubes. When all the small cubes are added, you got a big cube. Idea to wahi hai na, volume conservation, charge conservation. These numbers are different. Next one. Let's say we have a big sphere. Let's say charge is 2q, 2r, connected by a wire. We have a small sphere, minus q, r, they're very far. This is a switch. These are conducting shells. Remember in the beginning, I told you, whenever you connect two conductors, charge will transfer till the potential becomes same. So the question is, this is positive, this is negative, and you're connecting through a wire. Right? Find the final charges. When the switch is closed. How do you do this? Q by 2, Q by 2 होगा.
Size is not same.
See, first thing, so when you connect them, what happens? You connected them like this. Let's say Q charge went away from here. Okay, we don't know how much charge went. Let's say Q went away from here. How much charge is left here? 2Q minus small q. Agreed? If Q goes there, this will become minus Q plus small q. Agreed? Charges comes out, no? Kitna charge gaya, it should go there. Now, what is the potential of this shell? And they're very far, remember. That means they're not interacting with each other. So what is the potential of this shell? K charge by radius. What is the potential of this shell? K minus Q plus Q by radius. These two should be equal, na? whenever you connect two conductors, the charge will transfer till the potential becomes same. Is this clear? Then if you just solve them, k cancel ho jayega. 2q minus q by 2 will be minus q plus q. This will be 2q minus q is minus 2 capital Q plus 2 small q. So this guy will be 4q and this will be 3q. So q will be 4q. But this is not the answer. What is this? This is the charge that has flowed. This is the charge that has gone through the wire. This itself is a question. How much charge flows through the switch? So yeah, answer hoga 2q minus 4q by 3, 2q by 3. And this will be q by 3. That's your final answer, everyone. 2q by 3 and q by 3. Please check. Any doubts on this? Please ask. This is another standard model. This is what I'm telling you again. If you have just done the class ka problems and HCV and the exams which I'm conducting properly, mains mein scoring 75, 80 is not difficult. By the time we finish all the full syllabus, right? Physics mein we must have done at least 1200 questions in the entire notes. Aram se 1000 to 1200. That is a big source of solving. Most of you are not even revising the basic stuff. And that's why you're struggling.
Sir, they are hollow, no?
Yeah, hollow. Main problem why tha. You guys struggle because basic stuff you are struggling to do, basic problems. Clear with this? Next one. This is another good one. So we have a solid sphere with a cavity.
So in last question, that Q we have to put it in the formula and then we get.
Yeah. So we have a solid sphere with a cavity. This is O. This is O dash. This is actually a result also. I'll just prove it to you. And rho is the charge density, volume charge density. So you took a solid sphere and you made a cavity inside. We have done this kind of things in centromas, remember? So the question is, we want to find electric field inside the cavity. And we get a pretty interesting result actually. Find electric field inside the cavity. Think for a moment, then I'll show you. Every question that I'm doing, right, is an important models. Think how it is. Do you remember how I told you how to solve for cavities? Now see, this is what I'm saying. You know, Arish, you're asking us how do you get an idea? Do you remember whenever there's a cavity, how to solve? Do you remember what did I tell you? The first time you encountered cavities in physics is center of mass. Second time rotation. The first time when you encountered cavities, when you kuch bola that dialogue, what did I say?
Find for the total, then find for cavity, then subtract it.
So basically, you can't find for the cavity directly. You take the total, then you take this thing, and then you'll get that whatever you want, isn't it? Isn't that what I said?
Yes.
And isn't that what we did even for center of mass? So we are taking some random point here, P, okay? So this is O dash and this is O. So this is O, this is P, this is O dash and this is P. So that means if I can find the field due to this guy, and if I can find the field due to this guy, and if I subtract them, won't I get the answer? So look at this field here, even. K Q by R cube into OP bar. KQ small r by R cube, no? What is this field here? K small q by small r cube into O dash P bar. I'm using the formula KQ small r by R cube. Now from here we know density rho is nothing but Q by 4 by 3 pi R cube. This is also small q by 4 by 3 pi small r cube. So from here you can clearly see if I substitute now, you end up with this is 1 by epsilon r cube q by OP bar. This will be rho by 3 epsilon OP bar. This also will be small q by 4 pi epsilon r cube O dash P bar will be rho by 3 epsilon OP dash bar. So if you subtract E1 minus E2, you get rho by 3 epsilon OP bar minus O dash P bar. What is OP bar minus O dash P bar? Rho by 3 epsilon OO dash bar. Vector subtraction, everyone. See, O to P, O dash to P. So I'm saying OP bar minus O dash P bar is nothing but OO dash bar. Agreed? देखो ना, OO dash, if you look at this thing here, OP bar is nothing but OO dash bar plus O dash P bar. That is a vector thing which we did. So what we got the final result now, and this is important. Again, magnetism, you'll encounter this. You get a pretty nice result actually. So when I took this cavity here, this is O and this is O dash. Look at the result. We got field is rho by 3 epsilon O dash bar. Matlab, it will depend on the distance between the center of the cavity and the center of the sphere. It does not depend on the radius. And second thing, the direction is constant, meaning the field is always in this direction. See, it is parallel to O dash bar. So this was a question they asked in the exam. The field inside a cavity is what? The field inside a cavity is uniform, means it is constant. It's a uniform field. Magnitude and direction both are same. Result is important. Do have a look at the steps.
So the direction of field inside the cavity and the rest of the sphere will be same.
The rest of the sphere we don't know. Sirf cavity ka bata sakte hain.
Okay.
The rest of the sphere constant nahi hoga. It will be pretty weird. Within the cavity we can talk. Please have a look at this.
So if the center of the cavity and the center of the sphere are aligned, it will act like a hollow
Zero. Then hollow sphere ho jayega na. I'll give an example. Let's say someone gives you a sphere like this. This is O, this is O dash. And let's say O dash ka length is R by 2. Then inside na, the field will be like this. We are assuming it is positive. Huh? Negative, it will be reverse. So the field ka magnitude is rho by 3 epsilon O dash is R by 2. Ye tha magnitude. And the direction is O dash ka unit vector. Got it? It does depend on the distance between them. If suppose what you're saying, right? O and O dash will coincide. Matlab, this will be a concentric cavity, na? So O dash kitna ho jayega? 0. So the field is 0. There's no field inside the cavity. It's a good result, everyone. There are a lot of results. See, this is one thing, you know, medical students love electrostatics and electromagnetism. Medical people hate mechanics. Because mechanics, there is one model, you can have a lot of twisting. I can ask you different things. There are very few things to buy hard. In electromagnetism, ray optics, and all these chapters, right? You can buy hard a lot of stuff. And you can still go and answer in the exam. So generally, medical students don't like the mechanics because they don't want to think too much. They are trained a little differently, right? And you really don't want them to think too much in certain cases. Imagine they're doing an operation on you, right? And they're operating on something, lung or kidney. You really don't want them to think too much, right? Can we cut the kidney in a new, different way today? Just imagine. Right? So it is safe for them, right, to keep their mouth shut and just do the way the process is defined. Because if you go into operation theater and you start thinking new innovative ways on you don't want that to happen. So yeah, kind of works for them.
So why in the cavity it was parallel to O dash?
Because we proved it. Shaurya, you're asking as if I'm the one who decided. Who proved kiya to aaya tha result.
No, but that was without the cavity, na matlab.
What you're talking?
नहीं क्वेश्चन तो पूछा था कि cavity के बिना.
Question क्या पूछा था? Field inside the cavity पूछा था.
हाँ.
What do you want to say? No, you don't know what you want to say also. तू तो ना अलग level है तेरा. ठीक है, when you figured out, ask me under the class. At least when you're asking, you be clear na what you're asking. See, when you ask something, you can confuse the other guy. Acceptable. You yourself can't be confused. You're getting it? So that way, when you're asking something na, तुझे पता है, you have to confuse the other guy. चलेगा? You yourself are confused. That doesn't make sense, right? So yeah. Next thing, the last concept of self-energy. So what is the self-energy basically? This is energy required to assemble a system. Basically the same as potential energy. By bringing individual charges from infinity. So primarily we study for two shapes, okay? Derivation is not important. Hollow sphere. So see, if you have a hollow sphere like this, plus, do you remember how we define potential energy as? The sum of potential energy of all possible pairs. That means this charge and this charge will have a potential energy, potential, potential, like this, so on, right? Every charge will have a potential energy with every other charge. So if you add all of them, you will get some energy, isn't it? You can actually prove this from integration. The energy of a hollow shell is given by, it is called self-energy. See, if you have two charges, Q1, Q2, it is an interaction energy. The reason why we call it self-energy is because your own charges are interacting with each other. So hollow shell ka self-energy is K Q square by 2R. if you take a solid sphere where it is uniformly charged, the self energy will be 3kq square by 5r. Do mug up this results. Huh? In an exam like bits तो direct question था ये. Find the self energy of a solid sphere. Means in order to construct a solid sphere, you need to give this much energy to the system. Let me show you how they'll frame a question on this. Put it up. If you see today, we learned a lot of new things, huh? Self energy, field pressure, right? SHM in that oscillation, angular momentum conservation. So there are a lot of new things. So make sure to try all of them. HCV does not really have that kind of varieties, if you see. HCV is quite easy in that perspective. That's why I keep telling you, finish off HCV. I can send you a small sheet, or you can first of all do the class ka problems again. Or you can do my booklet ka level 3, level 4. If you're done with HCV, you're done with the class notes, you just ping me, sir, you tell me, sir, I'm done. I'll send you a small sheet, 30, 40 questions of more varieties. I think that will be better rather than you doing all different books. Or you can do pace booklet level 1, 2, 3. That is also good. Pace booklets are good. They've copied everything from Bansal. Pace ka ek hi problem hai. The material is not consistently, the segregation is not done. Easy question, tough question, kuch bhi aa jata hai suddenly from anywhere to anything. That is the only problem. Everyone's material is copied from everywhere. Isn't my material is also something great. I must have copied it from 3-4 institutes. That's why difference. These people just copied from one institute. So I kept more effort in copying from more people. Kind of. Let's see. Last question for the day. They're good. Facebook, they're good. See, question will be framed like this. Huh? So we have a hollow shell. So we have charges. Are uniformly distributed on a loosely on a hollow shell where particles are free to move. I'll show you the diagram. Matlab, this shell is there, na? So each particle, right, is like a charge. There are infinite particles. So radius is r, charge is q, and mass is m. Initially, everything is at rest. Then what happened? Due to repulsion, they will fly away from each other, right? They won't stay like that. If they're free to move, will they stay there like that? Due to repulsion, they move away from each other. They move away, maintaining a spherical shape. Because of symmetry, no matter how far they go, they maintain a sphere shape. So after some time, the sphere became like this. It became big. Charges are like this. So now what will happen? The charges will acquire some speed, right? Charges won't be at rest. They're going away. So charges must have gained some speed. Does that make sense? Initially, all the charges around the sphere of radius r, they started repelling and they started pushing each other. So all of them will gain velocity, right? So find the speed of the particles when the radius becomes double. Find the speed of the particles when the radius is double. So this is based on self energy. See, self energy is same as potential energy. कुछ difference नहीं है. The energy due to your own charges is called self energy. Initially, your kinetic energy is 0. Finally, you gain some kinetic energy. So loss in PE is gain in KE, right? Finish it off. Last one for the day. Next class, we will do relation between field and potential and maybe dipole ka little introduction. Continue solving it because I'm telling you now, pace people will suddenly rush up. I don't know what happens to them suddenly. Last year is still fine. COVID ka batch, so they did magic tricks only. They finished the chapter in 2 hours and they said we'll take doubt solving session and 3 days ago chapter khatam ho gaya tha. People didn't know chapter was over. Everything was online, na? And there was no one to care also what was happening. So in one way that was bad. In another way, it was because there's no need to go to the classes, right? If the students are pissed off, they used to switch off the cam and they used to study on their own. Which you guys are unable to do, right? And dusra COVID batch was bad, right? Exam got postponed 4 times. And they had 4 JEE mains attempts. Exam was going on till September. Most people gave up because of frustration, you know. They used to prepare, exam used to get postponed. Prepare, exam get postponed. But there are few, you know, so every week I used to sit and talk to them. And we literally took advantage of it. Huh? We literally took advantage of that COVID batch. Because everyone is getting frustrated and irritated. You know, in everyday program, you know, we used to make plans also. How to spend time other than studying. That is very important. If you're just sitting and studying, not valid for you guys right now. Once the portion gets over. Because your seniors were sitting and studying almost 12 to 14 hours per day. For 4 months. 4 months. Then you need a break. For people who are studying only 2 hours per day, you don't need a break. You're already taking a lot of breaks. There is this guy, huh? One guy sent a schedule yesterday. His schedule tha. Morning he woke up at 8. He went for cycling. Then he came back. He freshed up. He had food. 11 o'clock. He studied from 11 to 12:30. Then he had lunch. Then he slept. Then he woke up in the evening. He went for cycling. I said, "Kya kar rahe ho? Are you preparing for IIT or preparing for cycling competition?" And he was telling, "Sir, you only told him we should have physical activity." I said, "Yeah, I said physical activity आधा घंटा 1 घंटा होता है. 2 to 2 hours cycling क्या कर रहे हो? Full day is a holiday. Huh? He studied 2.5 hours. Cycling was more than 2.5 hours. 3 to 3.5 hours cycling कर रहा था. What to do, na? How to do this thing? See. So this is state 1. This is state 2. Potential energy is the self energy. K Q square by 2R. Kinetic energy 0. State 2. Potential energy, charge is same. K Q square by 2 times radius. Kinetic energy half mv square. Easy. Initial is equal to final. हो गया था, इतना ही करना था. KQ square by 2R is equal to KQ square by 4R plus half mv square. Simplify. This will be KQ square by 4R 2 by m root is V. Simplify that, you'll get the answer. So you guys will be able to handle up to question 54, 55, 55. You'll be able to handle up to 1 to 55 now. Total there are 75 questions. मतलब सिर्फ 20 questions ही बचा है. And you have time till next Wednesday. Huh? It is not one day. Today is what, Saturday and Sunday, Monday, Tuesday. You have 3 days in the middle, Wednesday if you can count. So try to wrap up this full chapter by Saturday. That will be a deadline. Last time I gave you 35 questions ka target. Agar usme at least 20 bhi kiya na, and now I'm saying 55. If you do even 40, you will have barely 30 questions left for Saturday, right? That's what I'm saying. When I say 35, chalo 35 nahi ho raha hai na, at least do 15, right? So keep working with that. Okay, so with that, we'll wrap up for the day. So next class, we'll meet up as usual on Wednesday again, 8:45. So any doubts, anything, stay back and ask, also free to you. So the fluid mechanics, the test is online till Tuesday. I think, yeah, people who are new, right? Hasni, you just ping me in WhatsApp. I'll send you the link. You have to register for the test.
Yes, sir.
Okay, so those are doubts, please stay back and ask, also free to leave. So